Today we're going to be talking all about the latest OLED developments from LG Display for 2025. We'll look at their new Gen 4 OLED technology, talk about the new Primary RGB Tandem panels and what that means for the OLED display market. We'll also discuss what the improvements and updates are for this year and what we can look forward to in the future from their technology. We'll look at the TV panel market as well as the monitor panel market before honing in a bit more on the monitor panel roadmap and the new panels being developed for this year and next. Keep in mind here that we're talking about LG Display, who are the panel manufacturer. They produce all of the WOLED technology panels used widely in the TV and monitor market, competing against Samsung Display's QD-OLED technology panels. We'll talk about which display manufacturers are using LG Display's WOLED panels as well, which includes LG Electronics, but also various others. If you want to know more about Samsung Display's 4th Gen 2025 QD-OLED technology, check out our other video linked in the description below. Let's start then by talking about what LG Display are calling their 4th generation of WOLED technology, which at the moment is focused on the TV market, but will in time also filter down to the smaller monitor panels too. So understanding the updates in the TV space gives us a nice indication of what we can expect from this technology in the monitor market later on as well. The biggest change to WOLED technology this year is the move to what they are calling a Primary RGB Tandem panel structure. Last year's Gen 3 panels had a stacked 3-layer structure of light-emitting layers, with 2 blue layers sandwiching a combined red and green layer. For Gen 4 this year, they've split out that combined layer into 2 distinct red and green layers, which both can emit their own light and gives us 4 stacked layers in total, with the 2 existing blue layers now paired with the separated red and green layers. This has created their so-called tandem RGB structure. With this new panel structure, they've also done away with the micro lens array or MLA that featured heavily on their Gen 3 panels over the last couple of years, and that was used to maximise the brightness at the time. Quite conveniently, the number of layers matches the panel generations here, so they've gone from 3 layers in Gen 3 to 4 layers in Gen 4, which makes this all nice and easy to remember. Although they do also refer to Meta 3.0 in some places as well, which messes up this convenient numbering system annoyingly. Let's just stick to calling it Gen 4 for ease, which seems to be their primary marketing name anyway for their latest 2025 panels. There are various benefits of making this change to the panel structure, with the headline being the big improvement to panel luminance. LG Display are now promoting a 4000 nits HDR peak brightness for white, a large 33% improvement over last year's Gen 3 panels. More layers emitting light leads to a brighter panel basically, even though they've also removed the MLA layer, which was used in the last generation to improve brightness. The higher brightness here in turn results in a higher contrast ratio as well. Importantly, we're not just talking about improvements to the smallest APL areas and the smallest HDR highlights. The 4000 nits figure applies to a 3% APL area for flash highlights, and so is a headline peak brightness number. But there's also significant improvements to specs for 10%, 25% and 100% APL, which will then translate to real-world improvements when viewing actual HDR content. For instance, 10% APL luminance has increased by 47%, while 25% APL luminance has increased by 33% as well. Even the full screen white or 100% APL luminance has increased by 60% from 250 nits in Gen 3 to 400 nits now in Gen 4. The brightness benefits are also applicable to colour brightness, now reaching up to 2100 nits peak, which is about a 40% improvement over Gen 3's 1500 nits. Remember that unlike QD-OLED panels, WOLED panels use a white subpixel to boost the overall brightness, and so that's why the combined RGB colour brightness is not as high as on the QD-OLED panels and doesn't add up to that 4000 nits number. Still, there's been a lot of focus from LG Display on improving brightness over the last couple of years in this area too, and it does show in their specs and panel performance. You can see the improvements made in various brightness specs across each WOLED generation here. We should keep in mind that with all of these headline panel brightness specs from both LG Display and Samsung Display, the real-world performance from actual TVs can be somewhat different, especially when they're set up to some normal colour temperature and not some overly cool or vivid preset mode designed to accentuate the brightness. Having said that, initial tests of early samples of these new panels suggest that the panel's native white point is closer to D65 anyway, and 4000 nits was achieved in demonstrations. We'll need to wait for further testing to understand how the headline specs translate into real-world performance across the different TVs and their various models in the future. but early demonstrations and side-by-side comparisons at CES and other events have shown impressive improvements in panel brightness. Another improvement that LG Display are promoting besides the panel brightness improvements is around energy saving. By enhancing the 4th generation OLED TV panel structure and power supply system, they've actually reduced the panel temperature and achieved around a 20% greater energy efficiency than the previous generation. They haven't really talked about longevity expectations with these new panels much, but we've reached out to LG Display for some kind of information or comment on that area. We'll pin a comment below when we get any kind of further information to share on that to supplement this video. LG Display are also promoting what they call their visual superiority of their 4th generation OLED technology. We already know that black depth is superior to QD OLED panels in brighter room environments, which is a well-known limitation in the competing Samsung display technology. The WOLED panels retain their black depth better as the ambient lighting increases, something that we've already seen on previous WOLED panels and measured in detail in the past. This year for Gen 4 panels, LG Display are also developing a special ultra anti-reflection filter for their TV panels that offsets both light reflections from the display surface and light absorbed and reflected inside the panel itself. They say that the new panels block 99% of internal and external light reflections now, helping to realise perfect black whether you're using the screen with the lights off or you're using the screen during the daytime in a brighter lit room. Based on samples showcased at CES in January, it appears that the coating is still what we'd consider glossy and pretty similar to the appearance of WOLED TV panels over the last couple of years too, but with better reflection handling and some improvements compared with older generations like, for instance, the CX models from 2020. The removal of the micro lens layer has made some small impact and improvement to black depth as well, which was a minor but noticeable improvement. Colour gamut has also been improved with the latest 4th gen WOLED panels and the shift to a 4-layer structure which increases the colour purity. LG Display now talk about a minor increase in the spec from 98.5% to 99.5% DCI-P3 coverage, but this is really a rather limited spec now to rely on at this stage and doesn't fully reflect the improvements. Early independent testing has revealed an increase in the Rec 2020 coverage from around 75% to 83%, for instance, between Gen 3 and Gen 4 panels. This should open up support for wider colour spaces where needed for HDR and offer a more vivid, colourful and saturated image than previous WOLED panels. The other promoted benefit of Gen 4 OLED is what LG Display are referring to as their human-friendly technologies, with the panel certified for low blue light levels, flicker-free operation and glare-free comfort. They've also got a focus on environmental impact for their products, and they're keen to highlight this as well. This shows their continued focus on eye health, biorhythms and the environment. You can see the various technology changes across each generation on this handy reference here. In 2025, the 4-stack panel will be produced in 48-inch, 55-inch, 65-inch, 77-inch and 83-inch size TV panels. So the smallest size you'll find a Gen 4 panel in will be 48-inch, but actually only in certain TV ranges. The first consumer products to use the 4th generation WOLED panels are the flagship LG G5, LG M5 and Panasonic Z95B OLED TVs, with more expected to be announced later this year. These new Gen 4 panels have a 4K resolution and 144Hz refresh rate, by the way. Note that the popular C-series LG OLED TV, which will be the C5 this year, and includes that 42-inch sized option that some people like to use as a monitor, will not feature the new 4-layer panels this year. All of the C5 models released this year, in all sizes, will actually use the older generation panels still. That's the TV space then, so what about desktop monitor panels? In regards to new 4th gen Primary RGB Tandem panels, LG Display have confirmed that there are plans to incorporate this technology in the future into the monitor size panels as well, although probably not for a little while. The first Gen 4 monitor panel would be a new 27-inch size panel with a 2560 by 1440 resolution and 240Hz refresh rate. The new 4th gen panel would be expected to offer a higher brightness than the current 27-inch WOLED panels they produce for monitors already, with a peak brightness spec of 1500 nits mentioned for a small 1.5% APL window area. There's even some suggestion that this could be as high as 2000 nits perhaps, but we'll have to wait and see later in the year. The There's also some improvements to full screen white, which would increase from 275 nits to 335 nits according to the initial specs currently provided. These specs are still to be finalised, but with the shift to a 4-layer structure, we do expect improvements in HDR brightness for these future monitor panels. The panel is listed as a 2025 product, but there's no firm expectations at the moment in terms of release date or production. This is different to the planned true RGB pixel layout panels that are expected to be developed at some point, by the way, although those could be primary RGB tandem structure, of course, still by the time that they're produced. We'll talk a bit more about those and other panels in a moment. They've also confirmed that the technology will gradually filter into other panel segments and sizes in time, but likely not until next year. The new panels being released this year, like the 45-inch 5K 2K ultra-wide panel, will continue to be based on the current structure using MLA Plus technology and the other existing technologies. Let's have a look at all of the LG.Display OLED monitor panels and roadmap in a bit more detail. While LG.Display don't really talk about panel generations for their monitors, we've split them up here into logical generations, which align with the planned 4th gen panel update this year as well. The first OLED monitor panels to be produced were all the way back in 2023 with a flat 27-inch 1440p 240Hz panel. That was used in loads of 27-inch OLED monitors being released that year. They also produced in 2023 a 45-inch ultra-wide curved panel, which had a 3440 by 1440 resolution, a 240Hz refresh rate, and a steep 800R curvature, although it was also used by Corsair to produce one bendable monitor too. We'll call those Gen 1 panels as they were produced in that first year in 2023 and mark the first iteration of their OLED monitor technology. Micro lens array, or MLA, was always actually a feature of their OLED monitor panels, used to help maximise the brightness on these smaller panels that have a higher pixel density and refresh rate than their TV panels. Last year, for 2024, for what we'll call Gen 2, we saw several new panel options introduced by LG Display. Firstly, they upgraded their 27-inch 1440p 240Hz panel to offer an improved peak brightness, up 30% and boosted now to 1300 nits peak brightness, compared to the 1000 nits of the first gen panels. They still referred to this as featuring MLA technology, not their later MLA Plus technology, by the way, so there was no change to the actual panel structure, it seems. So this probably just represents a more bullish approach to brightness output after an initial period testing the waters and balancing panel brightness against risks of image retention and burn-in for the desktop monitor market. At the same time as this brightness increase to the 27-inch panel, they made a natively glossy panel option available as well in this size, which was exclusively adopted by ASUS at the time for their ROG Strix XG27AQ DMG monitor. All of the other OLED monitors panels released to date have featured a matte anti-glare coating, which appears quite grainy compared with some other coating options, and so this natively glossy panel option was welcomed by many people. We've yet to see anyone else adopt this natively glossy panel so far, and LG Display haven't yet produced any other glossy panel sizes either. They also introduced 2 new ultra-wide panels in sizes of 34-inch and 39 inches last year in 2024 in their Gen 2, both offering a 3440 by 1440 resolution, 240Hz refresh rate, and a steep 800R curvature. These also had that higher 1300 nits peak brightness spec. Later in 2024, they made a fairly fundamental update to their panels, with the introduction of new 32-inch and 27-inch panels, which we'll talk about in a moment. For these new panels, which we'll call Gen 3 because of this update, they altered the sub-pixel layout to help improve text clarity and reduce issues with fringing and text clarity that had been a problem on the older panels. The pixel layout was changed as shown here to bring it closer to the expected layout for Windows, and this did a nice job of improving text clarity, especially where that was combined with an increased resolution and pixel density. For Gen 3 then, the first new panel introduced was a 31.5-inch or 32-inch sized option with a 4K resolution of 3840 by 2160. This gave it a 140 ppi pixel density, and it also had a 240Hz refresh rate. As well as the improved pixel density, this panel was the first to offer support for their dual mode function as well, allowing you to double the refresh rate up to 480Hz if you were willing to drop the resolution to 1080p. The other new Gen 3 panel was their 27-inch 1440p panel with a very high 480Hz refresh rate, the highest actually still from any currently available OLED monitor, although 500Hz Samsung Display QD-OLED panels are coming later in the year to take the lead in that area. Both the 32-inch and 27-inch Gen 3 panels went into mass production around May-June last year and have been adopted in various monitors already. The other change to those couple of Gen 3 panels was an update to use their MLA Plus panel structure, helping to maintain that 1300 nits brightness despite the higher pixel density on the 32-inch and the higher refresh rate on the 27-inch model, both of which can have an impact on panel brightness. MLA Plus helped maintain those same specs for those two new panels. On to the new panels then for 2025. These continue to be referred to here as Gen 3 panels for now in our naming scheme, as they continue to use the same panel structure, sub-pixel layout and MLA Plus technology that the couple of panels from the second half of 2024 offered. This year there's a big focus on higher pixel density and resolution ultra-wide panels, which is something that we discussed in detail in our recent video link below if you want to know more about the ultra-wide monitors and that part of the market. The first new panel to go into production in January was a new 45-inch ultra-wide panel with a 5120 by 2160 or 5K 2K resolution as it's known, increasing the pixel density significantly compared with the original Gen 1 panel from a couple of years ago. This panel remains curved at 800R, although LG Electronics have already announced and showcased a bendable monitor too for those who don't like the steep curvature. This panel will be available initially as a 165Hz refresh rate panel, with plans for a 240Hz version later in the year. It will also support a dual mode function like their 32-inch panel. Also planned for production later in Q4 this year are a couple of smaller ultra-wide panel options with the same 5120 by 1440 5K 2K resolution and 240Hz refresh rate. There's a 34-inch and a 39-inch size panel, which means you get increasingly higher pixel densities as the same resolution is packed into a smaller screen area. This will take pixel densities for ultra-wide panels to basically the equivalent of the new 27-inch 4K OLED panels. Both of these other ultra-wide panels are expected to have an 800R curvature again, although that's still to be confirmed, with bendable options also being possible again. These 34-inch and 39-inch ultra-wide panels are scheduled to go into production in Q4 2025 sometime, so we would maybe expect to see announcements of monitors using them around the time of CES next January. Also of note and being explored for 2025 development in the current Gen 3 panels is a natively glossy version of the 32-inch 4K panel already produced last year. We don't have a firm production timeline for this at the moment, but we're told LG Display are looking to offer this as another glossy option in a popular mainstream monitor size and spec, as those 32-inch 4K OLED monitors have done really well and become really popular over the last year or so. No word yet on any monitor that will adopt this panel either, but as and when it's produced, we will surely see some announced. Then we get into the later part of 2025 and the planned introduction of the first Gen 4 WOLED panel in the monitor space. That's using that new 4-stack primary RGB tandem structure that we've talked about earlier. We expect this to be produced towards the end of the year, but no firm timelines have been confirmed at the moment. This is a 27-inch panel with a 2560 by 1440 resolution and 240Hz refresh rate, and so the main benefit will be the increased brightness thanks to that new panel structure. If we look forward further to 2026, we know that LG Display are also exploring the potential to produce OLED panels with a true RGB pixel structure, doing away with the white boost subpixel and potentially therefore offering optimal text rendering from a standard pixel layout. We know that LG Display are looking at a 32-inch and a 27-inch size panel in this structure with a 3840 by 2160 4K resolution and 240Hz refresh rate expected. Other details and specs are still to be confirmed, but given that these aren't planned until next year, we expect they'll also be based on that 4th gen structure too. Note as well that LG Display don't have a 27-inch 4K OLED panel available this year, unlike Samsung Display, whose panel has already been widely adopted by monitor manufacturers. LG Display's 27-inch 4K OLED panel wouldn't be produced, it looks like, until next year, it seems, with those updated true RGB pixel layout panels. So there you go, that's a full rundown of all of the currently available and future WOLED monitor panels that we know about so far. Here's a handy reference table summary of all of the different panels and their technologies and specs, although note that the generation names are only what we've assigned and allocated as logically as we can here, as LG Display don't really talk about their monitor panels in this way as much. If you'd like to help support the content that we produce at TFT Central, you can find links to our Patreon below where you can get various perks like early access to new reviews and articles. Do let us know in the comments section below if you're thinking of buying an OLED monitor this year, or if you're going to wait for some of these new panels, or also what you're most excited for in the future in that OLED monitor market. Thank you for watching. We'll catch you next time.